Now we will discuss questions which is related to like similar to different, right? Similar items are going to different places. This is more of permutation, and different to similar, this is combination. So this we will discuss separately in the next session. Now I will discuss more about similar to different, and I'll try to cover all the questions which can be asked from similar to different. It's like similar items are distributing, right, in different two different people or two different places, etc., right? Let's take you have three persons A, B, C, and you need to distribute like 15 chocolates to A, B, C, right? So 15 identical chocolate to three people, right? That's what I mean by similar to different. Now let's take a question with that. I'll explain, right? I'll explain all the possible scenarios which can be asked from this similar to different cases, right? You are actually distributing similar items to different persons or different places or whatever it is, right? So it's like this. You have let's take 13 chocolates, okay? 13 chocolates, and you need to distribute among three people, right? So let's take three people, A, B, and C. You need to distribute 13 chocolates. So you can express it like this. So you have 13 chocolates in total. You need to give it to A, B, and C, right? So you can represent like this. So this is one of the representation which you need to know. Like if three persons are there, 13 chocolates, if I distribute, I can write it like this. Whatever I have given to A, whatever I have given to B, whatever I have given to C, if I add, I'll get 13. If I need to distribute to 4 people, it will become A plus B plus C plus D is equal to 14, right? Now, for this, you might have seen a direct formula, N plus R minus 1, CR minus 1, right? So if you just substitute the values, what is N here? N is 13, plus R means number of persons, right? Or number of places, 3. So R minus 1 means 2. N plus R minus 1, C R minus 1 is 2. You get answer as 15C2 direct. But the problem is you need to remember the formula. Now this is applicable only in this case. If the scenario is changed, I'll show you different other scenarios. The formula is not applicable. Then you need to remember different formulas. And there are cases where you don't have formula also, right? So what I'll do is I'll discuss a method, and we will try to extend that method to all the possible cases. Okay. Now before that, what is this 15C2 and 15P2, etc.? How will you write P2, C2, etc.? See, if you see 15C2, how will you write is like this only. This is 2. So from 15 take two previous terms, 15 into 14, and divided by 1 into 2. This is what 15C2. Okay. So what about 9C3? This is 3. So take 3 terms. So 9 into 8 into 7 divided by 1 into 2 into 3. Right? So what about 8C4? This is 4. Take 4 terms. So 8 into 7 into 6 into 5 divided by 1, 2, 3, 4. Right? Now what if 15P2? This is 2. So take 2 terms. You don't have denominator. If it is 9P3, you don't have this denominator, only numerator. If it is 8P4, you don't have this denominator, only numerator. Now I hope you might be knowing. Some of you may not know. If you don't know the formula, okay, leave it. It is not required for you. See, it is nothing but the NCR. If you need to find, it is nothing but n factorial divided by n minus r factorial into r factorial. So here you are finding NCR 15C2, right? N is 15 and r is 2. So what you are actually doing is 1, 2, 3, 4 up to 15 you are writing. That is what 15 factorial, n factorial divided by n minus r. That means you are writing up to 1, 2, 3 up to 13 you are writing, right? Then what is there? R factorial, r is 2. That means then 1 into 2, right? So what is effectively happening is this up to 13 and up to 13 getting cancelled, and 15 into 14 by 1 into 2, right? That is what you are actually writing here. Now if it is NPR, the formula is you don't have this r factorial, n factorial by n minus r factorial. So if you are writing, when you are writing 15P2, what is happening is this much is getting cancelled and this much is getting cancelled. This is not there, so that's why 14 into 15 without denominator. So actually there is no need to remember this formula. If it is 7C2, you will take 2 terms from 7, 7 into 6 divided by 1 into 2. If it is 7P2, you will just write the numerator, 2 terms. If it is 9C4, you will write 9, 8, 7, 6 divided by 1, 2, 3, 4. If it is 9P4, you will write 9, 8, 7, 6. There is no denominator, right? So if it is 15C2, which you have seen here, 15 into 14 divided by 1 into 2. right? And that you need to do. The calculation you can do anyway. That is nothing but 105. So how many ways you can distribute 13 chocolates among 3 persons? 13 identical chocolate to 3 different people? 105 ways. How you got it? N plus R minus 1 C R minus 1. But if I put different conditions, this formula is not useful, right? So that's why I'll give you a different method. It is going to be useful for you, right? So I hope you might have understood. You can write it as A plus B plus C is equal to 13. You have 13 chocolates. You need to distribute among 3 different people, right? So how you can do this? You can give 13 to A, 0, 0. You can give 0, 13, 0. You can give 12, 1, 0. You can give 1, 12, 0. You can give 0, 1, 12, right? You can give 6, 7, 0. You can give 5, 5, 3. So all these, for this also you have different ways. For this also you have different ways, right? So that's how you are actually getting total 105 different ways you can do, right? 105 is nothing but 15 C2. Now, one shortcut to remember this is, if you can write it as A plus B plus C is equal to 13. After writing this, so to write this, how many pluses are required? 2 pluses are required, right? To write this, 2 pluses are required. And see what is right hand side? 13. You add that pluses, so you get 15. What is this? 15. 15 is nothing but 13 plus 2. What is this 2? This is nothing but 2 pluses, right? And see how many pluses are there? 2 pluses. You'll write that 15C2. This is what you got by using the formula N R minus 1 C R minus 1. There N is 13, R minus 1 is 2. Here R minus 1 is 2, right? So that is what you are getting. So you can solve directly the moment you see A plus B plus C is equal to 13. Then see 2 pluses are required. Your answer is 15C2. If you need to distribute 13 chocolates to 4 people, you will write it as A plus B plus C plus D, which is equal to 16C3. Because right hand side is same, right? Right hand side is nothing but 13 itself. So 13 plus number of pluses here is 3, and this is also 3, right? So 16C3. If you apply the formula, N plus R minus 1 becomes 16, because R there is 4, R minus 1 is 3, N is 13, so 13 plus 3 16, C R minus 1 is again 3, right? Both are actually same. So rather than remembering the formula, keep it in mind in this way, right? If you can write it as A plus B plus C equal to 12, this right hand side you take 12 and plus number of pluses which is required and write like this. So your answer is 14C2. If you have 12 chocolates. If you have 13 chocolate, 15C2. So now it depends on the right hand side and depends on the number of people, you can directly mark the answer, right? If there are 10 people, you need to distribute 15 chocolate to 10 people. So you need to know A plus B, like that 10 people are there, so 9 pluses are required, right? So 15 plus 9, C9, right? That is nothing but 24 C9. So it's just a matter of knowing how many chocolates are there. I have 30 chocolates. I have 15 people, right? So how many pluses required? 14 pluses. So there is nothing but 44 C14. There is nothing but pluses. Why 44? 30 plus 14, right? So just need to know the right hand side. That means how many similar items are there. So if I have 15 similar chocolates, if I have 4 people, so 15 plus 3, 18 C3. 18 C3 is the answer. How will you write 18 C3? 18 into 17 into 16 divided by 1, 2, 3. 1 into 2 into 3. You get the answer. Now, what are the different possible questions they can ask you, right? See, here, how many ways you can distribute 13 chocolates to 3 people? You got the answer. A plus B plus C is equal to 13, right? So your answer is 15C2. That is nothing but 105 ways. Now, what is the second way in which they can ask you question? Now, here if you see, there is no restriction. If you want, you can give the 13 chocolate to A itself. You can keep these two are 0, right? Or if you want, you can give it to B and you can keep the other 0. Or if you want, you can give like this also. There is no restriction. Whatever you want, you can give it to anyone. But now there can be questions where they will tell that all should get at least one, right? A should get at least one, B should get at least one, C should get at least one, like that, right? So you will get a lower limit, okay? So now, see, the possible questions are like this only. You may get questions with no limit, no condition. That's what the question you have seen now. Then you may get a lower limit, right? That means at least 1 to all, or at least 1 to A, 2 to B, 3 to C, like that. So lower limit, again you can have 2 classification. Similar means 1 to all or 2 to all, 3 to all. Okay, that means same limits for all people or different limit for different lower limit for different people, like 1 to A, 2 to B, 3 to C. Then there is a possible question of giving upper limit, right? So you can give maximum 6 to A, maximum 7 to B, maximum 8 to C, like that, or maximum 6 to all people, not more than that. How many ways you can distribute? At most 6 chocolate to, like this, okay? Or A should get at most 6, B should get at most 6, C should get at most 6. Then in all these cases what we have discussed is we are distributing chocolate to these people, right? So we are just keep on changing this left hand side, right? We are distributing. Now there can be a possible question where the right hand side is changing. We'll look into that also. Right hand side is changing means, now here this right hand side is fixed as 13. Now they will tell you how many ways you can distribute at least 13 chocolate to 3 people. How many ways can you find the answer? No, because I can at least 13 means I can distribute 14, 15, 16, 17, 18, 1000, 2000, 1 crore, 2 crore, infinity, right? How many ways? Infinity. I cannot determine the answer. So how many ways you can distribute at least 13 chocolate means you understood that right hand side is varying and it can go up to infinity, so you cannot find the answer. So cannot be determined as your answer. If the question is about how many ways you can distribute at most 13 chocolate to 3 people, then this question is like I can give 1 chocolate, I can give 2 chocolate, I can give 3 chocolate. Okay, so let's suppose I have 13 with me. I can give 1 to A, 0, 0 this, rest of the 12 I can keep with me. It is effectively distributing to 4 people, right? 4th person is me, like that. Okay, I'll come to all the scenarios. So let's start off with the first case which I've told you, the lower limit, right? How will they give you the lower limit? The question will be like this: how many ways you can distribute 13 identical chocolate to 3 people such that all should get at least 1. Okay, now here the condition is all should get at least 1. So method is same. What you need to do is satisfy the condition. What is the condition which is given? Satisfy the condition. How will you do that? Give 1, 1, 1 to all. And how many ways you can do this? You can do only in one way. Okay, so you don't want to bother about that. So 3 is gone, 3 is already given. How much is left out? 10. Now if you see, this 10 which is left out I can distribute in any way because the condition is already satisfied. At least 1 I have given to all. Now this 10, entire 10, if I want, I can give it to A and 0, 0. Still the condition is satisfied because B got 1, C got 1. Right? A got 11, that doesn't matter. The condition is at least 1 to all. Right? So rest of the 10 I can distribute in any way. Now this become the previous question. Now this question has actually become a no limit question. That is no condition question. So you have A plus B plus C is equal to 10. How many ways you can do it? How many pluses required? 2 pluses. So you'll write it as 12C2. Now this you can do only in one way. So multiplication with 1 doesn't matter, right? So 12C2 is your answer. What is the question? This is a lower limit question, right? How many ways you can distribute 13 chocolate to 3 people such that all should get at least 1. I satisfy the condition, then apply the previous method. Then it becomes no limit question. Now if the question is something like this: how many ways you can distribute 13 chocolate to 3 people such that A should get 1, B should get 2, C should get 3. Then what you need to do? Do the same thing. Give 1 to A, 2 to B, 3 to C. And so for that purpose, in that case, how much is given? 6 is given. How much is left out? 7 is left out. Now this rest of the 7 I can distribute in any way because I satisfied the condition. I gave 1 to A, 2 to B and 3 to C. Now entire 7 I can give it to A. 0, 0. Still the condition is satisfied. C got at least 3. B got at least 2. Right? So this I can do in any way. That means now question become A plus B plus C is equal to 7. This anyway I can do only in one way. So you don't want to bother about that. So now A plus B plus C is 7, 2 pluses, that means answer is 9C2, right? So what all things we have discussed? A plus B plus C is equal to 13. What is the question? 13 chocolate to 3 people, right? Now first possibility is no condition, no limit. How many ways you can do it? 13 is the right hand side, 2 pluses, 15C2. Second case which I have discussed, similar limit, lower limit is there, but all are same. The limit which is given is same for all, right? At least 1 to all. Then what you will do? Give 1, 1, 1. See what is left out? 10 is left out, right? Now the question is converted to A plus B plus C equal to 10. I can get the answer as 12C2. If the lower limit is given as 2, 2, 2, means all should get at least 2. Then give 2 to each, 2 for all. Then 6 is gone. What is left out? 7. That you can distribute in 9C2 ways. Now if you have a lower limit and different lower limit, you satisfy the condition like 2 here, 3 here, 4 here. So 7, 9 is given, what is left out? 4 is left out. Now distribute this 4 in this way. Now your answer is 6C2. So what we have done is 13 chocolate to 3 people, 3 different situations. When there is no condition, when there is no limit, this is the case. When there is a lower limit which is similar in all for all people, we have done, right? You just satisfy the condition, then it will become the no limit condition. After satisfying the condition which is given, it become no limit question. Then different lower limit is given, right? Then also you satisfy the condition, then it become a no limit question, right? Now what is the next possible case? You will get upper limit. Now how will you make a question? You have the same story, a plus b plus c is equal to 13. You have 13 chocolate, 3 people. Now the question is how many ways you can distribute 13 chocolate to 3 people so that no one should get more than 7 chocolate, right? So here you have an upper limit, right? That means A should not get more than 7, B should not get more than 7, C should not get more than 7. So here A should be less than or equal to 7, B should be less than or equal to 7, C should be less than or equal to 7. So no one should get more than 7, right? That is a question. Okay, if the question is how many ways you can distribute 13 chocolates to 3 people, then what is the answer? 15C2 is your answer. This include the situations where A get more than 7, B get more than 7, C get more than 7, right? So these possibility 13, 0, 0, 12, 0, 1, etc. These possibilities are included, right? So you know how many ways you can distribute 13 chocolate to all the people. Now, if you know that, if you subtract where A, B and C is getting more than 7 chocolate, you will get the answer for this question. How many ways you can distribute 13 chocolate to 3 people such that no one should get more than 7, right? So if you know how many ways they can get more than 7, if you can find that and if you can subtract it from the total, you get the answer, right? So how will you find? So you need to violate the condition, right? So what is the condition here? Nobody should get more than 7. So how will you violate the condition? Give 8 to A, give 8 to B or give 8 to C. So let's see how many ways A can violate the condition, how many ways B can violate the condition, how many ways C can violate the condition, right? So how will you violate the condition? You give 8 to A, right? Now the condition is violated, right? So 8 chocolate is over, how much is left out? 5. Now how many ways A can violate the condition is what we are seeing now, right? So now A plus B plus C is equal to 5. Now this question is like in the previous way. So A already got 8, now rest of the 5, if you give it to A, B, C in any way the condition is violated. If you give the 5 to A, still the condition is violated. If you give 5 to B and C, then also A is getting more than 7, right? The condition is violated. So how many ways A can violate the condition? See, this can be done in how many ways? 7C2. How many ways B can violate the condition? B also will violate the condition in 7C2 ways, right? Because A plus B plus C is equal to 13. Now if B need to violate the condition means see how many ways you can distribute after giving 8 to B, right? You give 8 to B, so B violated, so how much is left out? 5 is left out. Now you distribute this 5 to ABC, right? So that is also 7C2. Now C will also violate the condition in 7C2 ways, right? So A, B and C will violate in 7C2 ways, so total is 3 into 7C2. Now how many ways you can do it in total, including all different kinds of arrangement? So you can do it in 15C2 ways, right? So total 15C2 ways you can distribute. Out of that, 3 into 7C2 is what? Where A, B and C is getting more than 7, right? So what is the condition? A, B, C should get less than 7. So what is the answer? 15C2 minus 3 into 7C2, right? How you got it? 15C2 is the total. 3 into 7C2 is number of ways A, B, C get more than 7 chocolates. So you get number of ways in which A, B, C will get less than 7 chocolates or at most 7 chocolate. So how you found this? 7C2 is nothing but A violating, 7C2 is again B violating, 7C2 ways again C will violate. That's why 3 into 7C2. Now, so what we have seen till now, we have seen questions with no limit. So similar to different question is what we are discussing, right? A plus B plus C is equal to 13. 13 identical chocolate to 3 people. First case is where there is no limit. Second case where we got lower limit. Within that we have seen 2 different categories, similar and the different limits, right? Now then we have seen upper limit, right? That means not more than 7, etc. Now Within this upper limit itself, you can get varying, like different limits you can get. It's like A, B, C, right? 3 people are there. You need to distribute 13 chocolates such that A should not get more than 7. That means less than or equal to 7. B should not get more than 8. C should not get more than 9. So at most 7 to A, 8 to B, and 9 to C. So what you need to do, total number of ways you can distribute this 13 chocolate is 15C2. You subtract how many different ways A violate the condition, how many ways B violate the condition, how many ways C violate the condition. So you need to see how many ways A violate, B violate, and C violate, subtract, you will get the answer for the question, right? What is the question? How many ways you can distribute 13 chocolate to 3 people such that A should not get more than 7, B should not get more than 8, C should not get more than 9. So what you need to do, see how many ways A violate. Give more than 7 to A, right? That means give 8 to A, right? How much is left out? 5 is left out. That you will distribute in the normal way, right? Now this becomes 7C2. Then you see how many ways B violates. So give 9 to B. Then this will become 4, right? Then you will get it as 6C2 ways B will violate. Now what you need to do? Give 10 to C. So you'll see how many ways C will violate, right? So this has become 3. So this is 5C2. So your answer is 15C2 minus 7C2 plus 6C2 plus 5C2. What is the 7C2? A violate the condition. 6C2, B violate the condition. 5C2, C violate the condition. 7C2 ways A will violate the condition. What does this mean? A get more than 7. So B get more than 8 in 6C2 ways. C get more than 9 in 5C2 ways. Now if you need to get the answer, 15C2 is nothing but 105, right? 7C2 how will you write? 7 into 6 divided by 2, 1 into 2, that is nothing but 21. Now 6 into 2 how will you write? 6 into 5, that is 30. 30 divided by 2, 15. 5C2 how will you write? 5 into 4, 20 divided by 2, that is 10, right? So subtract 46. 105 minus 46, you will get 59 as your answer. Now what was the answer in the previous case? 15C2 minus 3 into 7C2, right? 7C2 is 21. So 15C2 is 105 minus 3 into 21, that is 63. You get 42. So answer for the previous question where the limits are same. What is the condition? No one should get more than 7. A should not get more than 7, B should not get more than 7, C should not get more than 7, right? That means less than or equal to 7. There your answer was 42. Now here A should not get more than 7, B should not get more than 8, C should not get more than 9. Your answer is 59. How you got it? 15C2 minus 7C2 minus 6C2 minus 5C2. Now you understood how you got 7C2. A violate the condition, 6C2 B violate the condition, 5C2 C violate the condition. Now we have done with all the 5 questions which can be asked from this category, right? Similar to different, 3 people A, B, C is equal to 13, right? 13 identical chocolates, how many ways you can distribute to 3 people? What are the possibilities? See, now what we have discussed is this is constant. Next category I will discuss is this. See, there are 2 possibilities first. One is this, right hand side is constant, then right hand side is varying. So within right hand side constant we have discussed 5 possibility. What was that? When there is no limit, no condition, right? Then what was the answer? Just see right hand side, number of pluses, so you'll get 15C2 as your answer. If you want a formula, you have a formula n plus r minus 1, c r minus 1. That's not required anyway, because that is useless for the next 4 types of question that we are going to discuss. Now, then you can get lower limit, right? Lower limit with limits are same, like the ABC will get at least 1, or ABC will get at least 2, ABC will get at least 3, all will get at least 1, all will get at least 2, all will get at least 3, like that, right? So one of the example for that question, 13 chocolates, identical chocolates, you need to distribute among 3 people, all should get at least 1. So give 1, 1, 1, see how much is left out, 10 is left out. That now become a no limit condition question. You can distribute in any way, right? So the answer become, if 10 is left out, you will write 12C2. If you need to distribute at least 2 to all, distribute 2, that means 6 is over, 7 left out, then your answer become 9C2. An application question will be, you are going to a market, okay, you need to buy total, like let's say 13 fruits in all of 3 different types. Let's take apple, mango and banana. Okay, you need to buy 3 fruits, apple, mango and banana. So total number should be 13. So sum of apple, mango, banana, if you take, it should be 13, right? Then it is similar to, if there is no condition, your answer is 15C2 ways you can pick it. You can pick 13 apple, or you can pick 13 mango, or you can pick 13 bananas. But second case, if there is a condition, at least one from all, then one from apple, mango, banana. So you will do this 1, 1, 1. Then what is your answer? 12C2. Or at least 2 from all, then your answer is 9C2. Or the next possibility is 1 apple, right? Then 1 here, 2 mango and 3 banana. Then 6 is over. How much is left out? 7. That you can pick in any way. That 7 you can pick apple or mango or banana or whatever you want, right? So that 7 you will distribute, and you can distribute 9C2 ways. That's 7. After picking 1 apple, 2 mango and 3 bananas. Or the question can be, there are 13 chocolates, identical chocolate, you need to distribute among 3 people, A, B, C. A should get at least 1, B should get at least 2, C should get at least 3. Then also you will distribute 1 to A, 2 to B and 3 to C. See what is left out. 7 left out, you can distribute in this way. Then it becomes no limit question. Okay. Then after that what we have seen is upper limit, right? Upper limit and with similar limit and with different limits, right? Similar limit means how many ways you can distribute 13 chocolates to 3 people such that no one should get more than 7, right? So limit is less than or equal to 7. No one should get more than 7. So what you do? You see the possibilities, or you see the situations in which the condition is getting violated. How will you see that? You give 8 to A. So the condition is violated by A. See how many ways you can arrange, right? So you get 7C2 ways you can see the possibilities of A violating the condition. B also will violate in 7C2 ways. C also will violate in 7C2 ways. So total is 15C2 minus 3 into 7C2, you get the answer. Okay, now in this category, there is one exception. You may face some problem. See here, the upper limit which I have given is 7, right? 7 is more than half of the right hand side. But there are situations you may get upper limit which is less than half of the right hand side. What is right hand side? 13. Half of it means 6.5. Less than half means, let's take you are getting a limit like 5. Upper limit of 5. What does this mean? You have A plus B plus C is equal to 13. Now, how many ways you can distribute 13 chocolate to 3 people such that no one should get more than 5, right? So you understood this is upper limit, less than or equal to 5 is the condition. So what you need to do, you need to see how many ways A violate, B violate and C violate. So if you see here, how many ways A violate, you substitute 6 here, right? You give 6 to A, so A violated. So how much is left out? 7. Now this 7 you can distribute in any way, right? So A already have 6, A violated. This 7 you have enough flexibility, you give it to B. Then what will happen is B also have more than 6 or more than 5, right? Should not get more than 5. So here you can see a simultaneous violation. A also violated and B also violating. So this question become little tough or little time consuming because you need to avoid these double counting. What is the double counting? When there is a simultaneous violation. When you are seeing the violation of A, you can see B also violating. C also will violate here. If you give that 7 to C. Or if you write in this way, then 6-1, then also it is violated. If you write in this way, 6-1, then also it is violated. If you write 7-0 is violated, 0-7 is also violated. So all this double counting we need to avoid. So if the question is with upper limit and the upper limit is less than half of the right hand side, I hope you understood, right? So here upper limit is 5. This is less than half of the right hand side. This is little time consuming because there is a double counting and you need to avoid the double counting. So you keep this questions for round 2. See, upper limit question is generally easy but except this case. What is the case? If the upper limit which is given is less than half of the right hand side. But questions like this, here greater than half of the right hand side, right? So this is 7, so easy, right? You will see how many ways A violate, B violate and C violate, get it done. Now, what is the next category? Upper limit, where the limits are different, right? So here we have seen A should not get more than 7, right? That is less than or equal to 7. B should not get more than 8. C should not get more than 9, right? So we need to see the possibilities of the situations in which A violate the condition, B violate the condition and C violate the condition. So A we have seen 7C2, 6C2 ways B violate, 5C2 ways C violate, total is 15C2. So answer for this question, how many ways you can distribute 13 chocolate to 3 people A, B, C such that A should not get more than 7, B should not get more than 8, C should not get more than 9. You can solve by subtracting this from 7C2 plus 6C2 plus 5C2. Subtract 7C2 plus 6C2 plus 5C2 from 15C2. And you got the answer here, right? You got it as 59. Here you got it as 42. So we have done all these possibilities, right? When the right hand side is constant, we have done all the possibilities. These are the 5 questions which is possible. Now if you need to see application, one case we have discussed is, see, you need to buy, you went to market to buy fruits, right? You can buy apple, you can buy mango, you need to buy banana. These are the 3 fruits you need to buy. Total you are going to buy 13 fruits. Okay. Now if there is no limit, no condition, you can pick anything, right? You can pick 13 apple, 0 mango, 0 banana, or 13 mango, 0 apple and 0 banana. Okay. So what is your answer? 15C2. If there is a condition that you need to pick at least one from all, then what you need to do? Give 1, 1, 1. See, 3 is gone, then 10 is left out. Then what is your answer? 12C2. Right? If there is a condition you need to pick at least 2 from all, then you give 2, 2, 2. 6 is gone, 7 is left out. What is your answer? 9C2. Now, if the condition, so here the lower limit is there, the limit is same, right? Now, if you are getting a different lower limit, you should pick 1 apple minimum, at least 1 apple, at least 2 mangoes, at least 3 bananas, right? Then you do the same, satisfy the condition. 6 is gone, see how much is left out. What is your answer? 9C2. Rest of the 7 you can distribute in any way. You satisfy the condition. And this you can do in only one way, so there is no point in multiplying with 1 here, right? Or one more. Now, upper limit, how many ways you can pick 13 fruits in all, such that at most 7 from each fruit. So maximum is 7. So what you need to do, you need to see the total ways, 15C2. You need to see how many ways you will get the condition violated, right? How many ways more than 7 apple can be picked? How many ways more than 7 mangoes can be picked? How many ways more than 7 bananas can be picked? And subtract it, you will get the answer, right? So that we have already seen, apple, mango, banana, it should be 13, right? So how many ways A will violate the condition? You give 8 here, right? So 8, after giving, how much is left out? 5. Now this you can distribute among this anyway apple violated the condition, right? Means you can pick apple in more than 8 ways, right? So this is nothing but 7C2. Mango also can be done in that way. Banana can also be done in that way. So what is your answer? 15C2 minus 3 into 7C2. Now a typical application question can be, how many 3-digit numbers are there with a digit sum 13, right? Same as the question, there is no change, same as the method and same as the answer also. Only the expression or the words are different, right? So how many 3-digit numbers like ABC, if the number means 13, right? What does it mean? A plus B plus C is equal to 13. But there is an upper limit here which is not mentioned in the question, but you need to know that. In case of chocolate or mangoes and etc., you can distribute like this, 1300 is possible or 1210 is possible, right? Here that is not possible, because if you do this, it becomes 4-digit, right? So what you can do, maximum value of A, B, C can be 9. So there is a condition here, A, B, C should be less than or equal to 9. The maximum value which can take off is 9. So what you need to do here is, you need to see how many ways 13 can be distributed, or 13, that is 15C2, right? Then minus, you need to see how many ways the conditions are violated by A and B and C, right? How you do that? You put A is equal to 10, see how much is left out. If 10 is gone, 3 is there. How many ways you can do this? 5C2, right? Now 5C2 ways A violate the condition, 5C2 ways B also violate the condition. Now C also will violate in 5C2 ways, right? So you can put B is equal to 10. Then you see, you get 5C2. C also you do the same, you get it, right? So 3 into 5C2. Now 5C2 is nothing but 5 into 4 divided by 2, that is 10, right? So this is 105 minus 30, you will get it as 75. So how many 3-digit numbers are there with sum of digits 13? 75. What are they? I don't want to know. 670 is one number, 760 is another number, 850 is another number, 166 is another number. Not required, 75 such numbers are there, right? So what we did is, we got the total that we know, and we have seen how many ways A, B, C violate the condition. The 3 places will violate the condition, right? So 3 into 5C2, we got 75. Then we have seen upper limit, right? Varying upper limit, right? So you have 3 people, 13 chocolates. How many ways you can distribute 13 chocolate to 3 people, right? Thus still I can write it as 13. But the upper limits are different. A should not get more than 7. B should not get more than 8. C should not get more than 9, right? So what you need to do is, you need to first see the total 15C2 minus how many ways A violate, how many ways B violate, how many ways C violate. How to find the violation of A? You put this as 8. Then how much is left out? 5. That you can distribute in any way, right? You get 7C2. Then you need to see how many ways B violate, right? You put this as 9. then you get this as 6C2. Then you need to see how many ways C violate, that you need to put this as 10, then you will get this as 5C2. When you get the answer, you will get it as 59, right? So these are the possibilities, these are the possible 5 questions when the right hand side is a constant. Now let's see the possibilities in which the right hand side is varying. Right hand side is varying means what will be the question? How many ways you can distribute at most 13 chocolate to 3 people. So here also A plus B plus C is equal to 13 only. So here I am giving a condition for 13, right? So 2 condition. How many ways I can give at least 13 chocolate to 3 people? So here the condition is at least 13 chocolate to 3 people, greater than or equal to 13 chocolate. So how many ways you can do this? Can you find the answer? At least 13 chocolate means it can be 14, 15, 16, 100, 200, 300, 500, 1000, 2000, 2 crore, 5 crore or infinity. Okay, so nobody can find the answer for this question. Answer for this question is cannot be determined. If you are getting this, you can mark the answer faster, right? Cannot be determined. What is the question? How many ways you can distribute at least 13 chocolates to 3 people? At least 13 chocolate means there is no limit. It is infinity. Answer is also that. Cannot be determined, right? What is the next possible question? How many ways you can distribute at most 13 chocolate to 3 people? At most 13 means maximum 13 chocolate to 3 people. That means maximum 13 means if I don't want to distribute also. If I want to distribute only 1, I can keep 12 with me, I can give only 1. So you have a flexibility from 0 to 13. You can give either 0 or 1 or 2 or 3. That 0 I can give, right? I mean, I don't want to give at all. If I want, I can give 1 and I can keep the 12. If I want, I can give 2 like this and I can keep. If I want, I can give 3 like this or the 3 like this. Anyway, I can do. So what is actually happening is, in the previous case, this right hand side was fixed and I had no flexibility, right? That means I must have to distribute 13 chocolate to 3 people with the conditions which was given. Some conditions were there. In this case, I need to satisfy the condition and I need to distribute the entire chocolate. Now I have a flexibility. At most 13 I need to distribute. That means I can distribute even 1 also. I can distribute 2 also. I can distribute 12 also. I can distribute 13 also. Not a problem. If I want, I can distribute 13. That means what is actually happening here is, if I am distributing 3, right, 1 way in which I can do that, or 3 0 0, rest of the 10 I am keeping with me. If I am distributing 4, rest of the 9 I am keeping with me. So here it is nothing but distribution of 13 chocolate to 4 people. If you can understand in that way, if you can visualize in that way, this question is nothing but, the question what is given is, how many ways you can distribute at most 13 chocolate to 3 people. I can convert it as how many ways you can distribute 13 chocolate to 4 people, because here I have a flexibility that I can keep rest of the chocolate with me, right? So what you need to do here is, here I can keep rest of the chocolate. If I am giving 3 means I can keep 10. That means the 4th person is me, right? So I need to bring a dummy variable here, D. Now it can be like this, right? If I want to keep entire 13 with me, I can give 0, I can keep 13. Over. If I want to give 1, then I can keep 12 with me. If I want to give 1 1 1, I can keep 9 with me. You got it? Now it's just like distributing 13 chocolate to 4 people. And you know the answer for that. That is easy, right? That is, right hand side is 13. Now a number of pluses, if you see 3. Number of pluses, if you see, it's 3. So 16C3 is your answer. Earlier 15C2 because 2 pluses. Here you have 3 pluses because you have a dummy variable. You have 4 people. Who is the 4th person? You only, or me only, because I can keep with me. I hope you understood. So what was the condition? See, right hand side is varying. There are 2 possibilities. How many ways you can distribute at least 13 chocolate to 3 people? You cannot solve, cannot be determined. How many ways you can distribute? At most 13 means you have a flexibility from 0 to 13. That means if you don't want to distribute any chocolate, you can keep the 13 chocolate with you. That means you are distributing that to you only. If you want to give only 3, you can give it in any way and you can keep rest of the 9 with you. That means you are distributing to those 3 and you only. That means there are 4 people now. You need to see how many ways you can distribute for 13 chocolate to 4 people. And you know the method for that. Either you can go for n plus r minus 1 c r minus 1 and then your r become 4. Right, n is 13 now. So now we have covered complete, right? See what all things we have done. we have done all the cases where you can write a plus b is equal to a plus b plus c is equal to 13 or a constant. Right hand side is a constant. Then we have seen right hand side is varying, right? So there's nothing but similar to different. Different to similar cases is more of a combination. We'll do in a separate session. Okay. So here, what we have seen in the first case, there is no limit, right? And we know how to write the answer. So 15C2. When there is a lower limit and all the limits are same, satisfy the condition 1 1 1, then 10 is left out, distribute in the way you want, right? So 10 become 12C2. If it was 2 2 2, then you give 6, rest is 7. You can distribute the way you want, you get 9C2. If you need to distribute 1 2 3, 1 to A, B to 2 to B and 3 to C, give that, then 7 left out, then again 9C2. If you have an upper limit, right, that means less than or equal to 7. What you need to do? See the situations in which A violate the condition, B violate the condition and C violate the condition. Then total, that is 15C2 minus 3 into 7C2, that we got as A, B, C violating the conditions. Then we have seen different upper limit, less than or equal to 7, less than or equal to 8, less than or equal to 9. You need to separately see the conditions. You need to separately see the situations where A, B and C violate the condition and subtract it from 15C2, right? So you got it as 15C2 minus, right? You got it as 7C2 minus 6C2 minus 5C2, right? Now here you got the answer as 42, here you got the answer as 59. Now that is calculation part. Then we have seen right hand side varying. I told you, if it is greater than or equal to 13, you have no solution. It cannot be determined. Less than or equal to 13, at most, at least no solution. At most means you need to bring a dummy variable and solve it like what we have done, right? Now, if you can extend your thought, the questions like this also, right? You get questions like this, right? How many ways you can travel from A to B? This also you can visualize in this way. Whatever path you are adopting, you can go in this way, you can go in this way, or you go like this. Whatever is the path you are following, you need to travel 3 horizontal distance and 2 vertical distance. So the question is basically how many ways you can arise 3 horizontal and 2 vertical. Anyway, that you know how to solve it. Okay. Is there any discussion required? 5 factorial by 3 factorial into 2 factorial. There are some elements P of one type and Q of other type, right? So you'll write it as 5 factorial by 3 factorial, 2 factorial. Or rather than that, we can solve it just like this. 3 horizontal and 2 vertical, it is nothing but you can take whatever is more, right? H is more, that is 3, that is your right hand side, and whatever is less, this is your pluses. So you can write it as 5C2 directly. So whatever is more, you take your right hand side, and whatever is less, you take it as plus. Sometimes you get both as equal, then whatever you want you can take as right hand side, whatever you want you can take it as plus also. Like this. If you see this case, how many ways you can travel from A to B? 2 horizontal and 2 vertical. In this there is no condition. You can take the vertical as plus or horizontal as plus, vertical as right hand side or horizontal as right hand side. That means there is nothing but HHVV, right? You can take 2 as plus and 2 as right hand side. So your answer is 4C2. Now the question is if it is like this. So here 1, 2, 3, 4, 5 horizontal distance, 1, 2, 3, 4 vertical distance, right? So you need to arrange, and you have an answer for this. Otherwise you will solve 9 factorial by 5 factorial into 4 factorial, okay? But this also you can apply and you can solve it faster also. How? You see here H is more, right? 5. That you can take as right hand side. Pluses are 4, right? So your answer is 9C4. So 9C4 ways you can travel from A to B. Or if the question is something like this, how many ways you can travel from A to B via C? You need to see how many ways are there from A to C, right? So 2, this is 2 horizontal and 2 vertical. So that is nothing but 4C2. Then C to B means 3 horizontal, 2 vertical. So 3 is my right hand side. Then it is 5C2. Why multiplication? And because you need to travel from A to B via C. So and, okay, that rule we have already discussed, right? Now, so 4C2 into 5C2. Now, if the question is about what is the probability that a person who is traveling from A to B travel through C, then you know number of ways in which you will travel from A to B via C divided by total, that is 9C4. Then it is a probability question. What is the probability that a person traveling from A to B travel through C? You know how many ways you will travel through C divided by total number of ways.